Everyone, my name is Eric. I am a professor at the University of Alberta, and today I'm giving you a brief introduction to a course I'm teaching, which is Physics 144, that's called Newtonian Mechanics. And what I want to talk about today is give you an overview of that course and give you a little bit of introduction so that you can get a leg up on coursework or really decide whether it's something you want to take or not. And the purpose of this is to give you the brief introduction, go through the syllabus and policies, and then when we have our first day of class, we'll actually ask about questions rather than me going over all of this content in class. So to get started, I want to talk about why this course is the fundamental course in a physics degree and why it's an important course to take. And when we think about why physics in general, we want to think about the study and the discipline of our field and why somebody would actually want to study a subject that is perhaps not the most exciting aspect of modern science. Indeed, if you go out and you ask, well, why should I study physics? You'll find that using the impressive barometer of the number of Google hits associated with the phrase, you can search for the different fields that run around in science: psychology, biology, chemistry, and math. And these are the number of hits you get if you search for "I hate whatever subject it is," and you'll find that while not as reviled as math, physics is not the most loved discipline out there. So why would you pursue it if we are facing an uphill tide of public opinion? Well, perhaps it's these illuminating problems you can use in your everyday life, like this one that we can solve in our class, where we talk about suspending a bowling ball from the back of a moving truck that's accelerating down the road. We want to know how far that bowling ball displaces from the vertical, because this is something you clearly use in your everyday life, right? Or perhaps it's simply there to make sure that people can't get into medical school who can't pass basic physics. Now, this, of course, is not right because they no longer require physics for medical school, and you can go through your degree and everything, and you get into medical school, you're very smart, and you're a lot of things. But one of the jokes was just in the past, just to keep people who can't do physics from being doctors. But the reality is that physics is simply awesome. And I mean that in the original sense of the word, as in something that inspires awe. The study of physics has brought our society and civilization amazing things. The computer that you are watching this on, large explosions, next generation energy technologies like solar panels, nuclear reactors, both fission and fusion. It's at the heart of space flight. And you could even construct a bunch of other ideas that a lot of the sciences, like chemistry and therefore biology and everything, flow from the study of physics. And we're not going to cover all of them. We're not going to teach you how to build a laser in this class or most of the things on that list. We'll do some space travel, maybe some explosions. It's all great, but it's kind of something that we do a little bit later in the program. And with this amazing and exciting introduction out of the way, what are we actually going to do in this class? Well, we're going to study a subject called classical mechanics, which is the way big things like you move in usually highly idealized, relatively unrealistic situations, like these three little projectiles that you saw launched here and how far they go, given different launch conditions. You're a big thing, and atoms are small things. So if we leave the small if we move into the small things, the study of quantum mechanics becomes important. If these big things are moving very fast relative to the speed of light, the ideas of relativity become important. But we start out here because this is our common everyday existence. And so we want to start out studying with this. And we know how this moves. And if you're in this class, you have taken a classical mechanics course before in your past. It's a requirement to get into here. So what are we doing? Well, really, what we are learning is a very powerful technique. We are abstracting complicated situations that fill our world around them, and we are applying mathematics to those to make predictions about the future and the behavior of the system. Physics is often described as being built on math, and that math is unreasonably good at explaining the physical universe around us. So using the tenets of mathematics and applying them to the universe around us, we are able to take complicated situations like this jumping off of a bungee cord, or jumping off of a bridge with a bungee cord, and model it as a simple little block on the spring and make amazing predictions about what's going to happen in the system that are pretty darn good. And the more sophistication we put into the model, the better our prediction becomes. So what we are in the business of is predicting the future. We're using mathematics and our physical reality to make educated predictions about what's going to happen in the future. So if you want to know the future, we can study physics. So I often define physics as basically any intersection between mathematics and reality. It is impossible to separate the mathematics from what we're doing. And we're applying this mathematical modeling to our universe and reasoning forward from this. And so I'm an astrophysicist. I study systems like this galaxy here. And it's kind of wild that something that I certainly will never actually be able to go to and study and experience myself. I can make rich predictions about what this is doing and what it will look like billions of years into the future. It's amazing what we can do if we just use the rules of physics to understand the universe around us. So with that impassioned plea behind us, let's get into what's actually happening in this course. First off, I want to give you some information about whether you should take this course. This course is designed for students in physics programs and for people who want a foundation in physics theory. So the idea of using this mathematical modeling, it's widely applicable across a wide range of disciplines. And what we like to do is we like to say that we are learning to think like a physicist, which means being able to mathematically approximate and abstract the behaviors of systems. So we can apply this to biology, we can apply this to chemistry, we can apply this across a wide range of fields. At the heart of a lot of video games is the physics model. All of these things are built around our understanding of the universe and creating a model that describes something that's happening in the future. So if you're interested in that principle, in those principles, we can, this course may be for you. So we offer 2 courses in physics here that basically teach the same thing. We are in this course, Physics 144, and then there's this other course, which is Physics 124. 124 is an algebra-based physics course, but it fulfills every requirement that Physics 144 fulfills, including courses for the physics major. But we want our physics majors to take this course because it gives us the mathematical foundation for getting into second year and doing all of those amazing science applications. Because we're in here and we need that math basis, we require you to also be taking a calculus course. And so we have as a co-requisite, you either Math 117, 144, or AP/IB credit for Phys 114. Now you can take any of the calculus courses, but we recommend 144, as opposed to 134 and 154, because this focuses on physics problems and the two kind of connect with each other. In the language of the university, a co-requisite means that you are taking it at the same time or have previously taken it. So if you have an existing calculus credit, that fulfills a co-requisite. We generally recommend students take Math 144. Math 117 is an abstract formal math introductory course. It teaches you the lessons of proof, the richness of the study of analysis. It does not teach you as much about how to do the calculus that we need here in this course. In general, if you are in Math 117, you are strong enough in mathematics that you are able to pick up the techniques that we are discussing in class on your own, and you don't worry about the fact that you wait until the bitter end of Math 117 to learn the applications of some of the content. So Math 144 is the recommended course. If you have pre-existing math credit, awesome. Otherwise, you should be enrolled in Math 144, and you cannot drop Math 144 without also dropping out of Physics 144. That said, if you want to take a course that doesn't have the intensity of mathematics and work that this course is going to entail, Physics 124 is good for that. It's basically the Alberta Physics 20, but for real. There's a higher standard of requirements for what you're going through, and you'll be going through much of the similar material, but at a higher level of intensity. So, if you're still excited about this course, let's talk about how it works. This is the front page of the syllabus. It's colorful, it's got a lot of funny little diagrams on it, but it also encodes all of the important information. If we pop on over here, what you'll see is you have my contact information, when the office hours are, where we are having our class, all the basics are there. Talks about the materials that you will need, a textbook and a calculator. It talks about the different course components that we have, the weight of the grade that they will entail, roughly when they are due and when they're happening, where to find them, whether this funny little thing called the ACE clause is going to be important for that component, and the minimum score that's required to receive a passing grade in this class. If you fail to meet that minimum, you receive an F on your transcript at the end of the semester. Finally, down here, there's a schedule that kind of lays out the units of the course and what we'll be covering, and when a lot of our major due dates are presented. So that gives really the information you need in the course. If you flip through the rest of the 8-page syllabus, you'll find it's a bunch of tiny text that's largely the terms and conditions explaining all of this stuff. So while you are discouraged from clicking through the terms and conditions and hitting agree, it's all the details are in the back half or the back portion of the syllabus. So let's talk about what you need for this course. Basically, show up. You'll probably need access to the internet to cover a lot of the material on the course. If that's a struggle for you, check out the computers in the library. You can get a book. We use the book University Physics, 15th edition. Any previous edition will suffice. Physics has not changed in centuries for what we are taking. The teaching of it has evolved dramatically, but the core ideas are foundational to the study of physics. And so the textbook is a good alternative to listening to me. So I spend a lot of time blahing on a bunch of video lectures. You'll go ahead and if you want to just read the same content, it's all present in this textbook. You will never require a hard copy of this book. So if you want to buy an electronic copy or find other resources from the library or something, you can do that. So you don't actually need a physical copy for the textbook. Everything, it's optional. So no, we're not going to require you to have this book. On the other hand, calculators are optional, but not really. So some of the math in this class is not going to be nice numbers, especially when you get into things like fluids, where you'll have to do some sort of numerical evaluation of formulas. In general, we look for algebraic answers, so variables rather than numbers, but a calculator will be helpful. In this class, on exams, you can need a non-programmable calculator. These are calculators you shouldn't spend more than $20 on. If you have this beautiful Texas Instruments 84 that you're required to purchase for high school, it can help you outside of exams, but you will want a simple, dumb calculator on exams. So basic scientific calculator will do. These are the ones that I like. The Texas Instruments and the Casio ones tend to be the ones that are kind of the least expensive for what they are. You can get anything with an engineering gold sticker on it, but you'll want it for exams. Bottom line, no graphing calculators, and if your calculator is not a graphing calculator, but it has an integral or differential function, no calculus functions on it, you won't be able to use it in the class. Okay, we actually do a fair bit in class with electronics. You can have a phone, a tablet, a laptop in class. But we use this for using in-class polling, where I ask you some questions and you answer them. This uses a service called WooClap, and so it's from the University of Alberta, or provided through a contract through the University of Alberta. There'll be links that you can get access to at the beginning. We'll talk about that. You basically have a rule that you shouldn't distract others with your phone and computer. I mean, I find it very hard if there's a laptop in front of me to pay attention, especially if they're doing something fun like playing some Hearthstone or whatever. Very distracting to me. And so the first 3 rows of our lecture theater are a laptop-free zone. So it's basically anything with a large screen on it shouldn't be used in the first 3 rows of lecture, because if you are like me and have the attention span of a hummingbird, then you can come and sit in the first 3 rows of class and all that stuff will be behind you. Fundamentally, you're paying for this course. Thank you very much on behalf of the university, and you can engage with it however you like, but we want to give a space to the people who are have tiny attention spans like me. What? Sorry, go ahead. Okay. The course generally happens in 2-week blocks. The first week is just a separate unit, but then we have these 2-week units where we cover chunks of the material through the class. They all kind of stand alone. And at the start of every week, we have what's called a video quiz. You can do the video or the corresponding readings in the textbook, and that's due at 10 a.m. on Tuesdays, usually. What it is it consists of a single question where I want to know what's bothering you, because when we come to class, I don't want to spend time lecturing to you. Instead, you watch a bunch of new videos that I post to the YouTube, or you do the reading in the book, you answer the questions in the textbook, and then in class, we do fun, active things. We do examples, we do demos, you ask questions, I answer them, we'll do in-class activities. That's what we're doing in class. You don't need to hear me blather on. The internet will blather on for you. So every week at the beginning, we have a little video quiz. It's 1 question. What do you want to know? At the end of the 2-week block, there's 2 things that are due, both of which are online. The first is something that's called a building block. A little bit more on that later, which is basically basic problems in the unit. And then there's a written homework that's due to be scanned and uploaded into the system, and then you can start watching the videos for the following unit. So this is roughly our 2-week sequence here. So let's go over the individual course components and how they map to this class. We are doing 6 things in this class. We're doing a set of online quizzes, some things in the classroom. We're doing homework. We're doing a laboratory. There's a lab to this course. And then we have 2 exams, a midterm in October and then a final exam during the final exam period in December. These are their corresponding weights here. And I want to mostly explain the weights, what's the ACE clause, and this minimum score to pass. And essentially what I'll do is I will take your score in each of these components, I will average it up together with these weights, I'll translate it into a number, I'll apply some grade cutoffs, and you'll receive a letter grade at the end of the course. The average letter grade in this course is going to probably be around a B-. That's the historical course average for first-year courses. So we expect roughly a GPA of 2.6 with a typical letter grade of a B-. A lot of you may be looking at that and thinking, oh, that's a terrifying thing. It's just we do things differently here in university. The numbers that you've received in high school, we just use different scales and we kind of give a full range of things. You must understand that a B- here at the University of Alberta is an excellent grade. It shows that you show strong mastery of the material here. And if the class as a whole performing really well, this number will come up. If it's sort of a weaker class and relative to the historical average, it moves down. And we have ways of kind of calibrating that given final exam and other performance standards. So we set that, but you should expect that the average grade in the class, if you're getting the average score in the class, that translates to a letter grade of about a B minus. So how do we actually get to this letter grade and the final number? Let's go over the course components. First, online quizzes. These happen on our learning management system that's called Canvas. There's canvas.ualberta.ca. It'll take you right there. Our course will be present in it. And there are two types of quizzes. The first are these video/reading quizzes, and every week it's the same question. I just want one question from you that you want answered in class. Question is a complete sentence that ends in a question mark. It should be relevant to the content that's covered for the week, and it should show that you've actually thought about or done the material. Asking me where I get my fancy little shirts or something like that, not relevant to the course material, and therefore would not receive credit. So just give me a question that you want answered. I use this to inform what we do when we're together. The other course, the other thing online is called a building block. And building blocks are every unit we have some basic problems that I just kind of want you to know how to do. These are online quizzes. They use the system that's called STACK, which allows us to do good mathematics. And so this is a STACK question. It asks, what is the magnitude of a vector? And we use this unit vector notation that you'll learn about in the first unit. And so you just kind of want to know how to calculate this. Put the number into blank, hit check, it'll tell you whether it's right or wrong, and then you can move through the quiz here. You can take building blocks as many times as you want. There's 5 questions on a building block usually. Take as many times as you want. I give you the highest score that you achieve on that. And I set a due date for the end of the unit. So at the end of the 2-week period, it's good for you to have done these building blocks so that you're ready, but you can actually turn it in without penalty all the way up to when the final exam starts in December 11th. I want you to just have this as a resource where you're building up your skills in the class. So just do this. Sure, you can get somebody else to do these grades for you. That would defeat the purpose. The purpose is really to make sure you understand the basic skills that are required, because everything we do builds on these building blocks. Okay, then we talk about what we do in class. We do 2 separate things. The first is we'll do group and individual problem solving on paper. We'll actually do problems, I'll collect them, and I'll score them. You'll receive basically full credit if you kind of demonstrate a basic understanding of the problem, and we'll kind of move that and there. So more details when we're doing that in class. We also use this WooClap platform to do in-class polling. I can put up a question on the board, everybody can get on their devices, or use a piece of paper to answer the question. For both of these activities, I anticipate you can't make it to class every day. So 10% of your marks on this component excused automatically. Doesn't matter if you weren't there. If it's out of 100 points, I score it out of 90. So fantastic. And we'll just be able to get through and do some activities in class. I want to give you're spending your time. I want to give you a little bit of course credit for spending your time with us in class. Homework. Every unit we have a homework assignment. It's going to be 7 separate written assignments, each consisting of 5 or fewer problems, and they're due roughly every other week. It includes some optional and extra credit problems. Extra credit allows you to boost your homework score over 100%, which can sort of fill in other components of the course. If you feel like you're trying to make up for, I'd like to be doing better on my midterm, your homework extra credit can kind of fill in those points. You basically can work it on paper or on a tablet or whatever and upload scanned images into the Canvas platform. And the basic rule is every problem gets its own image, makes life a lot easier for the grading process. You've got to do your homework in what's called the style guide, which we use in first year physics. So it's linked off of our website, the Canvas website. It just sort of walks through how you're going to do problems. It's essentially asking you to be clear with your reasoning and don't substitute in numbers until the bitter end. So those pieces there, go ahead, read the style guide, and you can conform to it. The TAs are under instructions to be real jerks about marking with respect to the style guide. So have a read here. It's kind of like fiber. It's good for you to do this to build up your skills in presenting your thinking about physics. We have a midterm on October 23rd. We'll do it in class, a 75-minute exam. It'll cover units 1 through 4, which is basically up through energy. You'll need a pencil and paper, that non-programmable calculator. You get a handwritten formula sheet. So anything you want to handwrite on a regular size sheet of paper, like so, write it on down, bring it into class. There's going to be a simple formula sheet attached to the exam, but anything you want to write down on that is good. Note that photocopies and printouts are not handwritten. So I want you to put ink or pencil, graphite to paper and produce your own formula sheet. You get to keep it at the end of the exam and bring it to the final so you can sort of fill it out as you go. And then you also should bring your student ID. If you have academic accommodations, please start registering for them now so that they are in place by the time you take the midterm exam. We're a laboratory science course. Basically, you have a separate class that's run pretty independently of the lecture. You need to be enrolled in a section of lab for this course, or you need to have previously passed the lab and failed the rest of the course when passing the lab means larger than a 50% score. Labs don't start this week or next week or whenever. They start September 15th, I guess, depending when you watch this, but the labs start September 15th. And so if you're at the beginning of the semester, don't worry about going to lab. I'll make big announcements in class when it's time to start going here. You need to pass the lab to pass the course, and this prevents people from just saying, lab's a lot of work, I'm not going to go there and take the 20% hit to my grade. No, it's you need to actually pass the lab to pass the course. You will be happier if you have a laptop and or smartphone and bring it to lab. It allows you to collect your data and analyze it on your own time. We are regrettably not at the point in physics lab where you require safety equipment. When you get handed your dosimeter in physics, you know that you have arrived. That's next year. Final exam. 35%. It runs the entire course. So it covers everything, roughly equal weighting across all of our units. 3-hour exam, and you can bring the same materials that you do for the midterm: formula sheet, non-programmable calculator, writing, implements, and student ID. The date is set by the registrar's office. Currently, it's slated for December 11th at 8:30 in the morning. That's probably not going to change, but things can be strange. You need a 35% on the final exam to pass the course. And there's a reason for that that I'll get into later. But essentially, if you can't get a third of the points on the final exam, it is challenging to make the case that you have learned the material sufficiently well to go on to the next part of the course. Or next part of our physics sequence. The final exam is really important because it plays a role in the ACE clause. And the ACE clause gives you flexibility for how you're performing in the course. And the way it works is if your final exam is larger than your score in any component of the course, with the exception of lab and homework, I use your final exam score instead of what you actually earned to calculate your final grade. So for example, let's say in class activities, you don't make it to class that much. So you don't do these woo clap polls. You don't do as much of our little problems in class. Instead, you have other things to do, or you're sleeping, what have you. So if your class activities score is low, and let's say you get 38%, but you work independently really well, and you get a 65 on the final exam, what I will do is I will use that 65 in place of your actual class activity score when calculating your average. So that's, yeah, cool. We give you basically the benefit of the doubt. And so your final is kind of the floor of what you could actually score in the class. Now, let's say you can't take the midterm. You're sick, you're just got a lot of other midterms, you don't take it, you missed the midterm. I'll just use your final exam in place of your midterm score. You get a 0 on it, technically that's not a problem. We just use your final exam. So it's there to kind of give you these opportunities. But if you take the midterm and then you score higher on the final, we also raise your score on the midterm to whatever your final exam score is. So it's there to give you flexibility. And if you sort of end up tanking on one component of the course, then it gives you the opportunity to kind of replace and make up for it with your knowledge of physics on the final. Now, it can't replace the lab, and it can't replace your homework. These are things that I want you to do no matter what. That doesn't work there. But everything else in the course, we just take the average. Note that it replaces the component average, not individual assignments. Now, this gives you a lot of flexibility and freedom in this course. And so I want to stress that you are now fully fledged adult learners, and that means that you have to identify how you're going to make it through this material. This is a picture from my own university experiences. This was on the wall of one of the buildings, this little engraving here, and it said, "Use well thy freedom." So you've got a lot of demands on your time, and a lot of the hard part of university is making it through and managing to keep all of the balls in the air. I try to give you a lot of ways to do that in this course. But do not, I caution you to not rely on these approaches to necessarily make up. They should address concerns rather than sort of being an obvious route for, they should not necessarily be a plan going forward. It should just help you when things go sideways. So how do you get a grade? Well, you'll get a letter grade at the end of this course, but I can't tell you what the score that gets that grade is. I calculate raw scores based on course averages, and then I have an algorithm that I use to set grade boundaries and determine letter grades. It's likely going to have an average consistent with this B- average, but I have ways of checking whether the class is stronger or weaker than average, and I can make the case to the department and to the faculty that it was stronger or weaker and provide a different average. So that is basically the approach that goes through here. I'll try to give you signposts as to how the class is doing as a whole so that you know sort of where you sit relative to that average. In your syllabus, at the end of it, there's an exhaustive set of learning objectives. I basically build the final exam by going through that list of objectives and kind of establishing a set of questions, making sure a lot of them are addressed. If you go through and the in-class activities that we do and the midterm exam, these are good examples of questions on the final, but there are other ways of kind of giving an idea of what's happening. And so one thing you could do is actually see this in the wide and wonderful world of the Canvas course, and that is here. If you go on to Canvas and you find our course, Physics 144, and click on it, you'll see a little window like this. And we have links to a bunch of different places, and we have this modules up here. Now, what you'll see is you'll have things like the syllabus. You can click on that, and you will find our pretty colored syllabus and all of the extra text on it. You can also go back and join our class Discord. More on that in a little bit. Our class polling is right here. If you want to know what final exams and quizzes look like in the class, I've posted a bunch of in-class quizzes that I used to give. I'm not doing in-class quizzes this year. And then last year's final exam, complete with some answers, are embedded here. So if you want to know where we're going to end up, this should give you a little bit of an example of what's happening. If you miss a lot of class, more than that 10%, you can fill out an absence declaration form here. And then we have all of our YouTube videos in one place here, and you can actually watch videos all the way to the end of the class if you are a sucker for a glutton for punishment. But it's all here and ready to go. And our course structure is available in this modules unit. And at the top, we have things like the slides here that if you're looking for slides for this particular video and every other video, they're all embedded here. Solutions to the homework will show up here. There better not be any here. right now. See, they'll just appear here in time with the solution sets. I had a student contribute some study guides. They're available here. Your building blocks can get started here. This first teaches you how to use the system, and then building blocks is the actual exercise for that. And then you can get into the modules. I've released the first 2 modules, so you can do your, basically all of the coursework for the first 3 weeks here is available and ready to go. So that kind of covers what's available on the course website, but we also have a class Discord. You can join it from that link in Canvas. It takes you into a welcome page. This is the place where you can reach your peers and you can reach me pretty reliably in a kind of low stakes way. It's completely optional, but it's a communication channel. And since I am a creature of the internet, much like a lot of people in this world, you can kind of reach me in a lot of cases. And, you know, on average, I'm much happier talking about introductory physics than a lot of the things that are happening in my existence. You know, committee meetings and administrative policies that we have to deal with. I'd rather be talking about physics. It's fantastic. So you can go into the Discord, fire off questions. There's spaces on there for if you want to talk about other classes. You can discuss all of the homework, all of the in-class quiz content. It's all available there. I encourage you to ask questions. It's why you are here in this course and have a live human rather than just watching a bunch of videos available online and or asking ChatGPT to explain things to you and, you know, possibly burying in a few exciting errors. So that's where we are. It gives you all the resources. I hope this gives you some sense of what our class is going to look like. And if you have questions about this, I look forward to addressing them on the first day of class. So enjoy the rest of your time, and we will see you soon.